We're now going to look at how you can create a compound curve. And there's a number of different ways. I'll take you through one example here. Let's just edit the alignment geometry for this one here. So I'll pick the alignment and we'll go into the geometry editor. And let's assume that we want to add a compound curve off to another tangent. So really what we would need to know is our first curve, radius, and deflection angle, and then have it solve for the second curve. So what we could do, if we know we have a tangent here, let's first establish where our outgoing tangent should be located. And I'm just going to create a fixed line. So let's say that the outgoing tangent has to come somewhere along there. And now we can create a curve. So one way to do this, let's just create a floating curve from the end of this tangent. And bear with me here. So we're going to use the floating curve from entity, radius, and through a point. So that's going to solve for the point of tangency. Let's say the radius is going to be 250. The curve solution angle is less than 180. And the end point is going to be, let's just go right here. Okay. So that is our floating curve, and once again, when you have a floating curve, you have grips that allow you to edit that. This point of tangency is always going to be maintained with that floating curve, because the definition of a floating curve is that it has to have one point of tangency. So now what we could do is we could create a free curve between this floating curve and that fixed tangent. So we could now create a free curve between two entities in radius. And this is where you're going to have to bear with me for the geometry here. We'll see if we can get this to work. There's the incoming entity. There's the outgoing entity. The curve solution angle is less than 180. It's asking me if it's a compound or reverse curve. This is a compound curve. And let's put in a radius of 800. See if it solves for that. And it did. So we got lucky. So now it's solved for the point of curvature, the PCC point where your two curves join, and it's calculated this second radius of 1000. It's calculated its point of tangency along the other tangent. So just to summarize, what we did is we created a floating curve, we created a tangent, and then we created a free curve fillet between the floating curve and that tangent. Now another way to do that would be to create two floating curves. So we could now, let's go compound curve the other way. We'll create a floating curve from entity, radius, and through a point. And the radius is going to be 250, curve solution angle less than 180, and we'll drop that right there. Now we can create another floating curve. Let's do something different. Let's use entity, end, radius, and length. So there's the entity end. It's a clockwise curve, the radius of 500 and a length of 200. And so that's another way to create a compound curve. And then if we wanted to, we could create a tangent at the end of this, and it would be another floating tangent. If this curve established our tangent direction, we could use the floating line from the curve end and length. But if we wanted to establish our direction, we could solve for the point of tangency by using the floating line curve through point command. And that's what I'll do. And we'll attach to that entity, and I'll say that the line has to pass through that point. You can see here how it's solving for that point of tangency. So quite useful there to be able to create those compound curves in a few different methods.